Hello everyone, today I would like to explain how to create a grid of lights in Blender. By grid of lights, I mean a mesh light pair that is managed as a single object and replicated multiple times within a defined space. Creating a grid of meshes is straightforward, for example by using a double array modifier. With some additional setup, it is also possible to create a grid of lights either by parenting a light object to a vertex and applying a double array modifier, or by using geometry nodes. What I wanted to achieve instead was to directly replicate the mesh light pair as a single unit within a grid. For this specific use case, I was unable to find a working solution either on YouTube or through GPT. Eventually, I found a solution by working directly with geometry nodes. Let's go through the procedure step by step. First, we need a lamp mesh object. In this example, we will use a neon lamp mesh. Next, we need a light object. For convenience, we will use an area light. Once we have the elements we want to combine, we select the lamp mesh object and switch to the Geometry Nodes editor. We click New to create a new Geometry Nodes modifier and start with the default setup, connecting the Group Input node directly to the Group Output node. Next, we add a Grid node. The grid node requires four parameters, the size x and size y, which define the dimensions of the area in which the points will be distributed, and the vertices x and vertices y, which define the number of vertices generated along each axis. For example, we can set size x equals 4m and size y equals 10m, with vertices x equals 3 on the shorter side and vertices y equals 6 on the longer side. At this point, we need to convert the grid mesh into points. To do this, we add a Mesh to Points node. This node takes the mesh generated by the grid as input and outputs a set of points corresponding to the mesh vertices. After generating the grid points, we add an instance on Points node and connect the output of Mesh to Points to its points input. To visualize the result, we connect our original lamp mesh to the instance input of the instance on Points node. At this stage, we obtain a grid of lamp meshes, generated as an alternative to using a double array modifier. What is the difference compared to the modifier-based solution? With array modifiers, we explicitly define the number of instances and the offset distance between them. With this geometry nodes approach, instead, we define the area in which the instances should be distributed and the number of vertices, and Blender automatically places the instances accordingly. Depending on the desired result, one approach may be more suitable than the other. Now let's see how to add the light object to the grid as well. We add an object info node and specify our area light as the referenced object. It is essential to enable the as instance option, otherwise, the setup will not work correctly. To combine the geometry of the lamp mesh with the geometry of the light, we add a join geometry node and connect both the lamp mesh instance and the light instance to its inputs. As a final step, we connect the rotation output of the object info node to the rotation input of the instance on Points node. At this point, we have successfully created a grid composed of mesh light instance pairs. If the light appears offset relative to the mesh, we can insert a set position node after the object info node and specify the positional offset to apply to the light relative to the mesh. The lamp mesh now acts as the reference object for positioning the entire grid within the scene. Rotating the mesh object will rotate the entire grid, while rotating the light object will rotate each individual light instance within the grid. Limitations of this approach. Since this setup is based on instances, it is not possible to modify the light power or intensity on a per instance basis. All lights will share the same values. It is also not possible to independently control the visibility or on-off state of individual lights, for example, to create a sequential lighting effect in a corridor. For such use cases, a setup based on array modifiers is more appropriate. I hope this explanation has been helpful. See you next time.